department head, the supervisor, and fellow department members. I am going to deliver my research presentation, and it is about a hybrid algorithm to solve multimodal travel assessment problem based on genetic algorithms. Did you know about multimodal optimization? It is the study of algorithms to solve optimization problems associated with two or more best solutions, as opposed to a single best solution. It is mainly divided into two parts, discrete MMO and continuous MMO. If a multimodal optimization problem that having a discrete domain, then it is called as discrete MMO. Travel salesman problem is a discrete optimization problem where a given a list of cities and the distances between each pair of cities, what is the shortest possible route that salesman can visit each city exactly once and come back to the origin city. That is simply called as travel salesman problem. You can see in this travel salesman map that has several parts. So likewise, if your TSP problem is having more than one optimum routes, it is called as multimodal travel salesman problem. My aim is to develop a hybrid algorithm based on genetic algorithm to solve multimodal travel assessment problem and obtain multiple routes. These are my research objectives. Review the nature of the MMTSP and available methods. Check the suitability of genetic algorithms to solve it. Apply suitable modifications to the genetic algorithm and implement new hybrid algorithm based on genetic algorithm to solve MMTSPs. And finally, compare and evaluate the result with existing result. Let's enter my literature review. Here, I have chosen to explain only the most relevant papers due to the time constraint. This paper helps to find the concept for my research. They have done their research for continuous domain and I have used it for discrete domain. So far, only 5 researchers have been done for MMTSPs. Those are shown in this red color box. All of these research papers have used niche strategy. So this is an open research area for hybridization with MMTSPs. I have used their result for my comparison. Let's see the summary of literature review. They have used population sizes between 50 to 150. Optimal solution was arrived in less than 1500 iterations. They have used new strategies and those are too complex. There are some drawbacks. Use large population sizes even for small TSP instances. Most of the methods are unable to find all the solutions with accuracy. Some methods are too complex. So let's enter my methodology. Actually, I want to find an accurate but a simple approach using nature-inspired algorithm. As I said before, concept of hybrid algorithm was taken from a recent paper with continuous multimodal optimization. I have tested the same modification by selecting ant colony system algorithm and the genetic algorithm for discrete domain and that was applied for genetic algorithm to obtain multiple solutions. Let's see my implementation process. First, implement genetic algorithm and then hybrid with ant colony system. And after that, add modifications to the hybrid genetic algorithm. And after that, testing results and the comparison part. And finally, statistical analysis. That's how I implemented. So, let's say quick explanation of genetic algorithm.
Initial population is randomly generated. Each individual has its own characteristics. We make the creatures walk and calculate the distance traveled for each of them. We then randomly select two creatures that perform well, generating a new creature. In the mating process, the child gets some characteristics from one parent and some from the other. A random mutation occurs, which slightly changes some of these characteristics. Using this process with several creatures, the next generation is created.
Now you have an initial idea about the genetic algorithm. So let's enter my hybrid algorithm. This is the first part of ant colony system. First, initialize parameter values, and after that, define the objective functions for ant colony system. Each ant is positioned on a starting city. They have to apply state transition rule to incrementally build a solution by using local pheromone updating rule. After each ant finish their tour, then apply global pheromone updating rule. Whole process is repeated by multiple times. Finally, it returns the best ant fitness value and we take it as threshold value for further processing. This is the second part of modified genetic algorithm. Now you have an initial idea about genetic algorithm through previous video. So it's easy to understand. First, generate initial population and then initialize parameter values. Now, we enter the while loop. First, evaluate the fitness values for initial population and check those fitness values with threshold value. If you can find matching chromosome less than threshold value, then put them into the archive box and replace the position with newly created random chromosomes. And after that, set flag value into 0. If no matching chromosome, and then flag value increment by 1. So iteration wise, flag value reach to the constant value. Let's say flag value equal to 100. At the same time, archive box is still empty. That means population is not evolving. We need to change the population. So first, flag value set to 0 and then create random integer between upper half of the population size. And after that, create random positions. And finally, replace that random positions with newly created random chromosomes. That is the modification part. You can see in this red color box. After that, normal process happened like previous video. Select two parental chromosomes by using rank selection. For crossover, use partially mapped crossover method. And for mutation, use swap mutation. Mutated chromosome set as the new population. Whole process repeats by the multiple times and finally it returns the multiple optimal solutions in the archive box. That's how it works. When talk about my research dataset, these are the parameters which I have used. By using these links, you can access my dataset. This is the overview of the problem and the solution set. Let's enter my result section. These are the multiple optimal solutions and this is the best fitness value graph. Here, iteration wise, it was reached to the shortest optimal solution. And those are the multiple paths for the same TSP instance. When compare my result with others, I have taken simple 19 TSP instance. For that, here I can achieve the max level of optimal solutions like published results. Let's talk about the performance measure values. Those are PR and SR. PR means average percentage of peaks found by the algorithm over all runs and the SR means percentage of successful runs. For that, I use these two equations. This is the complete summary of the comparison result. These are the 20 TSP instances which I have used, and these are the number of cities, and these are the optimal dual length, and these are the number of previous number of solutions of the previous studies, and this is the number of solutions which my algorithm achieved, and these are the performance measure values. Here, all the highlighted areas are the greater than or equal solutions with previous. So, I have succeed 13 problems out of 20. Other 7 problems also have multiple solutions, although not as much as published results. So let's enter conclusions. Here, ACS MODJ approach is presented, and these are the optimal parameter values which I have used, and we did not apply niching strategy to our model, but the new hybrid algorithm is successful because we can get multiple optimal solutions for each 20 problems. We have to improve further this algorithm to get more solutions for large scale problems as a future action. Finally, we have already submitted our research paper for ICT-AR conference 2021, and these are the references which I have followed. And thank you very much for your time and consideration.